Hello and welcome to Nightshade. Today we are about to start a new tutorial series. We will make a slicer game in Unity 3D where you will learn to cut fruits in pieces, animations, and some other 3D techniques you might be unfamiliar with. This game is originally by NativeCoders from CodeCanyon. You can check out their page from the link in the description. It's gonna be fun and it's going to be a long series. So make sure you hit that subscribe so you don't miss the other parts. So the tools we need to make the game are Unity, Visual Studio or any code editor with Unity SDK support, Blender for 3D handling. It's completely free to use, you can download from this link, and Photoshop. Now, before we start, I would like to make one thing clear, that I will not be able to teach you how to create and model 3D fruits. Since it's a completely separate domain, only a 3D designer can show you how to make them. Although you cannot learn to model objects just by watching, it only comes from practice. Instead, I will put download links in the description for all the 3D objects I will use in the game. So let's begin. So, open Unity. Now, make sure the 3D is selected and then give the project a name about Ultimate Slicer. Give it a location and click Create. So once our project is created, let's create some folder structure. Right click, create folder, name it Animations, create new folder, Materials. Similarly, create folders for Models, Scripts, Prefabs, Textures. Okay, now download the 3D models and textures folder from the link in the description. Unzip the folder and you will see something like this. The models and textures. Now go back to the project, select the models folder, right click, import new assets. Navigate to the models folder and select ground. This is actually going to be our conveyor belt for our fruits and veggies. Now drag and drop the ground in the main scene. It's pretty big, so instead of tweaking the position and sizing, I have predefined proportions. You can use them if you want. Select the ground object and set position X to 972, position Y to 480.2739, position Z to negative 203.8571, and set the scale Z to 0.9989554. Now expand the ground object, select the ground and set the position X to negative 1614. Okay, now let's make the camera actually see this ground object. Because if you go into the game view, you will see that camera cannot see this ground. So let's set the positioning of the camera. Select the main camera and go to the camera properties. Set clear flags from skybox to solid color and set the background color to more orange-like. And then select the position X to negative 1300, position Y to 1013.6, and position Z to negative 341.26. And then set the rotation X to 40, rotation Y to 79.63. Sorry. In the clipping planes, set far to 666 9.7. Check the game view. That's more like it. Okay, now go to the lighting tab here and change the environment lighting source to gradient. Set the sky color to this. Set the equator color to more lighter. And set the ground color to white. Now scroll a little downward and check the fog and set the fog color same as the camera background. Now set the mode to linear, set the start to 1100 and the end like 2000. Now go check in the game. That's more like it. Okay, now let's rotate our view from here because this view, the camera view, is being projected from this side. That's more like it. Okay, now we are going to create a point here where all the fruits and vegetable will be pop into the scene and slide from there to here. So here, right click and create an empty game object. I'm going to name it spawn point and then set its position X to 1032, position Y to 525.7 and position Z to negative 2.2.0074. That's more like it. Now for testing purpose, let's create a 3D cube object to initialize here. I'm going to right click 3D cube. Let's scale it a bit, like 150, 150, 150. It's only for temporary, don't take it too seriously. And position doesn't matter too. Now let's add a rigid body to our cube. And then check the is kinematic so it's not affected by the gravity. Okay, now we're getting started to the scripting side. So in the script folder, let's create a new script. Create C# script. Let's name it moveable object. Let's open it up in Visual Studio. So what this script will actually do is to cause the object to move from one position to another position by sliding. So now in the script, let's zoom a little bit. Remove the start function, we don't need it. Let's create a variable, public float speed, and change the update method to fixed update for better performance. And right here, transform dot translate negative vector 3 dot right into time dot delta time into the speed, and it is related to whatever the space in the game world. Alright, so the script is ready. Let's go back into the Unity, select the cube, and then drag this movable script to here, and let's set the speed to 600. Alright, so the cube is ready. Let's drag the cube into the prefabs folder and delete it from here. Similarly, let's create another 3D object for variety. This is going to be a sphere. Same thing, we are going to add a rigid body. Set is kinematic true. And I'm going to drag the same script to the sphere as well. Set the speed to 600. Okay, and then drag the sphere into the prefabs and delete it from here. Okay, now we are going to actually render these objects from this point. So after initiating, these objects will slide from there to here automatically. To spawn this object, let's create an empty game object. Let's name it object spawner. Its position doesn't matter. And then in the scripts folder, let's create another C# script. Let's name it object spawner. Okay, now let's add the object spawner script to our object spawner object. Drag it here. Now let's open up the script in the Visual Studio. Okay, we're in the Visual Studio. Let's delete the start function and change the update to fixed update. And now let's create a variable. Name it public, an array of game objects. For the time being, let's call it vegetables. This is going to be the list of vegetables, and you can say the 3D objects that will be rendered in the scene. And now create public transform the spawn point. The spawn point is actually the point where the vegetables will spawn from. And now let's create public float interval between spawn. As the name suggests, it is the interval between each vegetable spawn in the scene. And for our own convenience, we're going to create a float variable to reset the timer. Let's name it spawn between time. And now in the fixed update, I'm going to write if spawn between time is less than equal to 0. Inside the if statement, I'm going to take a random int variable, int rand equal to random dot range between 0 and the number of vegetables that can be spawned in the scene, length. And now I'm going to instantiate any vegetable from this array based on this variable. So I'm going to write instantiate vegetables at the index of any random number that we got here. And to which position? This is going to be our spawn point dot position, and we're going to do quaternion to identity. And write spawn between time equal to interval between spawn. And then in the else part, if the spawn between time is bigger than 0, I'm going to reduce it by each frame. Time dot delta time. So what is actually happening here? For example, if I say the interval between each spawn is 1 second. So what it's gonna do in the fixed update, it's gonna check if the spawn between time is less than equal to 0. For the first time, it will be true because we have not set the variable. So it's gonna instantiate the vegetable and set the spawn between time equal to 1 second. So the next time this function hits, which could be less than 1 second, it's gonna check if the statement is true. which it will be false because we have set it 1. So it's gonna reduce the spawn between time by each frame. Okay, so it's not gonna instantiate the vegetable, and the next time this function hits, it will be less than or equal to 0 because of this statement, and then it's gonna instantiate other vegetable, and the cycle will continue indefinitely. Okay, now our script is ready, so let's go back to the Unity and select the object spawner. So in the script here, I have the vegetables array I declared in the script here. So I'm going to place in the size property, since I only have 2 objects for now, so I'm going to put 2. So I have 2 elements here. So I'm going to go in the prefab and drag the cube to element 0 and drag the sphere to element 1. Alright, so the spawn point is actually this point where the objects will render. So I'm going to drag the spawn point over here, and the interval between spawn, let's make it 0.5. Okay, so there is one problem in the sphere prefab. If I select it, I have to scale it to 150, 150, 150, 150. Same as the cube. Alright, so now if we run the game, you will see that our objects have started to render. So you see that from this point the square and the circles are being rendered. That looks great, but as you see, there is a problem here, that the objects keep getting instantiated, and the game size is just gonna increase. It can cause some memory leak problems. So let's place an invisible wall here, so when the objects collide with the wall outside of the camera view, the object will destroy itself. So let's do this. Okay, now in the project pane, right click and create empty game object. Let's name it Destroyer. Okay, now let's set the coordinates for the Destroyer object. Its position X is going to be negative 1900. Position Y is going to be 525.7. Position Z to negative 202. Okay, that's good. So now let's add a box collider component and set the collider size X to 75, Y to 820, and Z to 930. Okay, so our wall is placed at the right position. So let's set the isTrigger true, and let's create a C# script. I'm going to call it Destroyer. Open up the script in the Visual Studio. Okay, this is Destroyer script, so let's zoom in, remove all of these functions, we don't need them, and write void on trigger enter collider, which is going to be our collided object. Then we're going to write destroy collided object dot game object. Okay, so now let's go back in the Unity, and now in the script folder, well, actually the destroy script is outside, so let's place it properly in the scripts folder. Alright, so now let's run the game and test the destroy script. Well, looks like it's working just fine. So no memory leak. Alright, we are good to go. Alright, now let's stick the knife in the scene. Right click and create an empty game object. Let's name it knife parent. Alright, so now let's set the position X to negative 900 and position Y to 568 and position Z to negative 420. Our knife will actually be here. Alright, so now in the models folder, right click and import new asset. Go into the folder you just downloaded and select the knife object. Drag and drop the knife object in the knife parent. Right, now select the knife, set its position X to negative 70, position Y to 65 and position Z to 113. Set the rotation Y to negative 90 and rotation Z to negative 54. And let's scale it to 0.89. Alright, so now let's check the game view. Okay, looks fine. Now let's texturize our knife. So in the textures folder, right click and import. Navigate to the textures folder you just downloaded and select the knife. Alright, so now in the materials folder, right click, create material, name it knife matte, and in the albedo select the knife and set the smoothness to 0. Alright, so now let's expand the knife object here. Select the bottom part and drag the material over here and select the upper part and drag the material here. Okay, we have the textures here, so don't worry about the lack of shadows and the lighting. We'll do it afterward. So now we have the knife, so let's create a knife cutting animation. Okay, now select the knife parent object. Go into the animations tab and let's create an animation. Let's call it cut. Okay, so the only property we'll be using here is the rotation property. So click add property here, transform and select rotation. The duration will be to 0.5. So let's drag it over here and at 0.3 add a keyframe here. So when the animation hits 0.3 second, 0.03 seconds, it's gonna rotate at the X angle. So let's hit record, select the 0.3 second mark and set the rotation X to 45. I think that's fine. Click it, and if I run it here, I think that looks just fine. Okay guys, I'm gonna have to end this tutorial part here. So in the next part we'll be controlling the knife animation based on our input, and we'll put some moving particle effects, and we'll finally put the fruits and vegetables in the scene. So I'm working on the next part and it will be here sooner than you think. So make sure you subscribe so you don't miss it. Have a nice and healthy week, and I'll see you in the next part.